And we are back. So we are going to start to learn how to write kind of more elegant functions in Mathematica. So previously we do like function equals, cosine of x times y times, log of x times exponential of z, etc., etc., etc. And we could evaluate this function or plot this function, and we could, look at our function and then do slash dot. X goes to 1, y goes to 2, z goes to 10, and we can look at some of these values. Let's do x goes to 10. So we can look at that and evaluate numerically, but it's kind of laborious to kind of add those values in. So instead, if we want to kind of make it a little bit nicer, we can define function x underscore y underscore z underscore, and then colon equal, and then this function. This creates it and treats it. See, right now I'm getting this error because I previously defined function. So I need to do clear function, and I could do it now. Now it's good. So now I could do the same thing, 10 to 10. I can look at this numerically. Much nicer, right? So easy to kind of write that function and show it. You could do it with fun of 10 of y and z, and just keep it in that format as well. And you'll see that your x, y, and z, again, they're not defined. So that's the key and the really, really, really nice little tool that you have there. So we can go ahead and basically define functions in that way. All right, that's excellent. We can also write functions as conditions. So what do we mean by that? Sometimes we want to work with like piecewise functions, right? Or where a certain range of x's, it gives us a different value. So here we can utilize if function. So I could use my if function, and I could do it in terms of x underscore, and I could do if x is greater than 0, give me, let's see, give me the cosine of x. If x is less than 0, so if x is greater than 0, it's going to do this. If it's not, then it's going to do, let's say for negative, what should we do? What's kind of a fun function? Let's just do x cubed. So let's do if function. So if I do a 1, for example, cosine of 1, excellent. If I do if function of minus 10, we get minus 1,000. So you can see and play around with those values. So if functions and these conditional functions are really kind of useful tools to kind of look at. You also don't even have to value it. I could just put this and say, dude, give me 16. So for example, this gives me 16, and this would still give me the same value. I can say this is blah, and then it'll give me blah. So if functions are pretty useful and kind of handy, actually. So you can do a lot of true, false, and those things. It's actually quite fun. Now, finally, we are going to get into solving functions and using our solve and our double equal signs that we kind of talked about previously, and ignore this simultaneously. So let's look at some functions. So I'm going to do function, my f1 is going to be equal to, let's do 5 times x squared, times x squared. Let's do minus y squared, minus 10, and then let's do f2 is equal to minus 17 times x squared plus 0.5y plus 17, and let's do finally fun simp equals 10 times x squared plus 18x, quadratic formula. Hopefully we should remember that, but again, we don't ever have to solve those values again. So I can solve fun simp, set this equal to 0, because again, I got to do the double equal signs. If I don't, see, it's already giving me an error. So Mathematica is already improved in this other, in this 13.0. So solve for this in terms of, solve it in terms of x, and I can get those values. So these are basically non-real values. I can also say solve in terms of x and only give me the real solutions, so the non-imaginary solution, so reals, and it gives me nothing because there's no values there. I could solve for f1 in terms of x. Solve, let's set this equal to 0, solve in terms of x. I could ask to solve in terms of y. Give me that. I can ask to solve f1 equals 19, f2 set equal to minus 19, and I could solve both of these simultaneously for x and y. 2 equations, 2 unknowns, and it could spit out some kind of nasty answer here. So, you can solve multiple equations simultaneously, and we're going to get to use this quite a bit once we get into lecture 5 and tensors and mechanics and all those kind of fun equations. So, in the next video, we'll just kind of go over what are some common mistakes you'll occur or see in Mathematica, and then that'll be all lecture 1. And then we'll get on to lecture 2, which is fun plotting. So, I'll see you all in the next video. Thanks. Bye.